Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the event horizon here on Astronomy.FM radio. And that means, of course, it is another Friday night. This one happens to be November the 24th, 2017, 9 o'clock in the evening for those of us here in the eastern portion of North America. So universal time, that would put it at 2 o'clock in the morning, November the 25th, Saturday morning, 2017. So yes, for the next hour, we are live. My name is Marty Kunz with my co-host.
Good evening, everybody. It's me, Evetts, 2 Echo 0, Lima Uniform November.
And we want to say hi to everybody in the chat room, too, tonight.
Yes, we have ourselves, Marty, Starstorm, Sickos. Thank you, Starstorm. Sickos, Psychotic, Glenn T, Black Projects, Twisted Edge. And I'm going to say this right at the beginning of the show. If you're not in the chat room, you're missing out a big chunk of the show. Because why is that? Because we have the links, we have all the fun conversations, and we have some of our good friends in here. And it's very simple. If you can't find the link on the main web page, go to our Facebook page, Astronomy.FM. You can't miss it. It's got an aurora picture. It's the main cover. And look for the posts about the show, because it'll have the link to the chat room. Very simple to use chat room. Don't need no passwords, don't need to give an email address. Just simply type a name and come in. And please, everybody, remember, this is a family-friendly zone.
That's right. But if you want to pay us cash, come in the chat room. We'll accept it happily.
Now, are we talking gold press latinum, cube, bitcoins, or what, Marty?
I'm thinking just slip me a $5 when you pass me on the street. That'll do just fine.
Man, Marty, you are cheap.
Well, let's see. So do we want to go with what we were talking about earlier?
Oh,
right
yes.
At the beginning?
Let's have a bit of fun. Straight
all right, I think we're going to do that.
Okay. Now, if you can believe it or not, a flat earther is planning to launch a rocket to prove that we're wrong and the Earth is flat and not curved. I kid you not. This guy does not believe in science. He has built a steam-powered rocket. He doesn't believe in trigonometry. He thinks Euclid fixed it, along with Aristotle and everybody else. Excuse me. Hey, Astro One, nice to see you, my friend. So, can't believe it. A steam rocket. Not going to get you very far.
Too bad it doesn't. I saw a picture of it. Too bad it doesn't actually look like a steampunk rocket. Now, that would be kind of cool on its own.
But he's built this apparently from salvage part. The link is from NPR. And we can always trust NPR, can't we?
There's a bunch of them out there. I mean, bunch of ways of finding this article.
Anyway, it's a jury request to overturn 2 millennia of scientific knowledge. It's cost them about $20,000, according to AP, and it goes without saying, but we'll say anything, do not try this at home or anywhere else, because you're not qualified. And apart from that, you'll probably get a visit from Homeland Security, the FBI, NASA, the US Air Force, and most likely the US Marines too.
I don't know if you get a visit, because mostly for like amateur rocketry that'll go several miles up, you just have to file a flight plan with the FAA and have certain parameters about recovery and location, stuff like that. So, and got to be out in certain deserted areas and stuff like that. So it should be okay to do it from out the desert type stuff.
I wouldn't have thought so, not in this day and age.
I'm sure the amateur rocketeers are still making launches out there.
but I can guarantee that they've been through all the vetting and everything, and I don't think this guy even plans to file a flight ban.
Yeah, we'll find out.
Come on, let's face it. Given the amount of air traffic, and if he's even in Arizona, it's crazy.
Now he does only planning on
get shut down by Area 51.
There you go. Now he does only planning on going up to about 1,800 feet, like quarter mile, something like that is all. I did read a little bit on the article. I think he was saying, well, this is kind of a test flight to see if it would, he would be able to do that. He says, I'm kind of behind the eight ball on rocketry. It's like, so that means you do believe that there is rocketry out there and people are better at it than you. So you have to start building your own just to do that. And yeah, well, know that you can just climb up, drive up a mountain and, get up about a mile up, and you can go a couple of miles up.
And what it will do, it will just completely destroy the flat Earth theory.
Mm-hmm. Well, then what else is there? Airplane, small airplane, easily a couple of miles. Charter a jet and get for the $20,000, you can charter a executive jet and get up around 35,000 feet with that, I think.
Yeah.
So it's not that hard to do, but what's he really trying to prove? I don't know. It's just one of those things. Maybe he's trying to make enough money to recover his loss and then have a profit out of it, or sell a book about it or something like that. Just make a bunch of money.
Well, I'm going to pop you in another little story.
Well, I'll get one more comment on this. I think he's going to prove that the Earth is splat.
Yeah, that's what he's going to be.
Yep.
Anyway, for those of you who like good fun and games, this is going back a wee bit in time. It's going back to let's pop into the TARDIS and do this. We're going back to January the 26th of 2016, when Neil deGrasse Tyson got into a rap battle over flat Earth theory. I think this guy is just so incredible. I just love how he takes these people on. He doesn't care. You start in on him on science, and particularly on science that is his home turf. I hope to heck you know your subject. Anyway, something to look up and enjoy later. Neil deGrasse Tyson having a rap battle on Twitter. Mm-hmm. I thoroughly enjoyed it the first time around. I thought it was just hilarious.
I did look up their website, and they've got some lists of reasons why this against arguments, and it usually goes along like starts out trying to be a little logical, and then just goes total and emotional response, like because I think this is the way it should be, and throws out science completely or misinterprets any science, and then twists it around, and then basically because I don't believe anything about anything, and all fake excuses and whatever. It's like, so you can't so you can't actually argue with a flat earther like that because they're basically not emotionally stable enough to discuss anything logically that I could tell.
Yeah, I think it's I just don't understand it. We've had enough pictures from the moon. We've had pictures from orbit which clearly show it's a sphere.
Yeah, well, that's when their emotions.
Perfect sphere, but
that's when their emotions take over and say, "Oh no, there's not real pictures, and the astronauts really didn't go up, and they lied, and they're all paid off." And like, yeah, that's the way the argument goes. You try to prove it with something logical and evidence, and then you just get an emotional response to the opposite. So no point even arguing it with anybody. Just not going to listen.
Just let them go on their merry way and be happy with themselves that they think they've got it all right and the rest of us are wrong.
That's right. Yep. Well,
I wonder if there's a way you could argue it with general or special relativity.
No, they got arguments using relativity against it.
Yeah.
Mm-hmm. Yeah, they actually bring up relativity.
There's always,
they bring up relativity to prove why the Earth is flat. So there you go. Impossible. Exactly.
I really wish that we had Mr. Feynman and we had Albert around for that one. That would be a classic, I think. Feynman and Albert Einstein, flat earthers.
Yeah, it's just you don't argue with people that can't discuss and accept any evidence. I mean, You could tell them there's a pencil on the table and they say it's a cat. So you're done.
Yeah. Hey, I like the cat, dude. Can I draw with it?
There you go.
Or even better, can the cat draw for itself?
Can a cat draw itself? In a box. Can a cat draw a picture of a box? And then is it in there?
Is this the box where the cat is alive, but in the other universe it's dead?
That's correct. And it could be either one.
This is true.
Just make that entire circle.
Sir Patrick Moore and Sir Arthur C. Clarke were members of Flat Earth Society during the 60s when they attended Flat Earth Society meetings in London, yes. And I seem to remember Patrick Moore and Sir Arthur C. Clarke driving them totally, utterly nuts.
I know, I was going to say. Yeah, you either try to drive them nuts or they drive you totally nuts and stuff like that. So sometimes it's just fun. Sometimes I go on to a radio show where they talk about aliens. And again, the same types don't want to listen to logic because I think it hits their pocketbook if logic pervades their, their fun stuff.
Logically speaking, if you're doing your pocketbook right, then using logic actually makes your pocketbook better.
Logic, not necessarily. No, more fake stuff earns more money than real science.
Yeah, I know. It's sad, really.
Like our buddy Stephen Ramsden, the Charlie Bates Solar Astronomy Project. Every time something fake comes up, or you can look up, like what's it, celestial crystallography. There's more books in a bookstore on that stuff than there is on real science, for instance. And same thing with the internet. Posts of fake science gets a lot more hits than real science.
Well, as Black Projects is pointing out in the chat room, and this is why everybody, you need to be in it when we're live, because between the pair of them, and they were a formidable tag team once they got going, kind of like Sir Patrick and Commander Henry Hatfield used to be over the moon, and selenography. They used to drive the Flat Earth bonkers because they listened. And then they just totally made the flat earthers look totally like incomplete idiots. That's always fun to do as well. I think in a lot of cases. Yeah,
it's if you're good at making points and counterpoints, and you know all the counterpoints, somebody else's counterpoints, and you have a really good way of countering their counterpoints and stuff like that. You got to be really on your toes and be really good at discussing something, and instead of saying because the scientists say so, that doesn't work with them. You have to be able to talk it through, and if you can't talk it through, you falter, and then they seem to win because if they have a better speaker, basically.
Well, as Black Project points out in chat, Sir Patrick Moore had a room in his house full of astrology books, and he said, "Know your enemy, dear boy."
There you go. Yep.
And he was quite good at it. They had these people on saying, "Oh, Mars is in the ascendant, and there's gonna be trouble, and there's gonna be rioting." Yeah, you silly idiot! You've just told people to go out and riot because their excuse is Mars is in the ascendant. Duh. So of course there was a riot. Oh, good grief! Yeah. But unfortunately, yes, you do have these people who really don't like science because it completely invalidates in a lot of cases, their core beliefs.
Yes, not realizing that their everyday life they use science.
Exactly.
Everybody is a scientist. Like, for instance, I always use this analogy. If you're in a car, you're driving, and you're going to pull out onto a busy street, do you use science or do you look up in a book what you should do or read the paper? No, you look both ways. You judge the distance of the vehicles coming at you. You judge their speed and figure out the time it should take for them to be at your intersecting point. And you basically use science to figure out if you should pull out or not. So if you figure the car's far enough away at the speed that they're going, I will have plenty of time to get out into traffic without them honking. That's science. That's observation. Yes, observation and measurement is what science is. The opposite of that is, like I said, go look up in a book, look up in a table of books, and decide if the numbers are, whatever lined up on your odometer if you should pull out now or wait till another time. That's
as I say, it's kind of like for a rough analogy, it's like like World War II dogfighting with fighter planes. You're not shooting at where the other guy is. You're shooting where you expect him to be.
Yep.
In the next X, you know how long it takes his aircraft to cover X amount of space. So therefore, you aim your guns at where he should theoretically be, mathematically speaking.
That's right.
And then you start shooting.
Yep.
And that's when you shoot him down.
That's right.
Not if you're shooting right at him as you see him, but where he's going to be in the next 30 seconds.
That's right. So
great link. Thank you, Black Projects. That YouTube in there. Patrick Moore investigates flat Earth and other theories in Can You Speak Venusian? And he actually had a chap on who was insistent that he speaks fluent Venusian and was speaking to them as he was being recorded on the show. And I have to admit, it was very, very good in entertainment.
There you go. So everybody's a scientist, whether you realize it or not.
Absolutely. You use science every day. You switch on your light, you're using science. You boot your computer, you're using science. Most people may not know how to use their computer more effectively, but you're still using science at the end of the day.
That's right.
So let's just take it a little bit further and do some real science.
That's right. So let's do some science.
Absolutely.
All right. Let's see. Let's go with, since this is the Event Horizon Friday. By the way, American traditional holiday right now is, yesterday, it's called Thanksgiving. It's kind of a feast type of celebration, and it goes back to the original colonists that came over here, and they had a really good meal. So it's basically a traditional feast. The day after is now called Black Friday because that's when a lot of people actually go shopping, and the stores make lots of money, and their books end up in the black, hopefully. So keeping with that tradition, NASA is calling today Black Hole Friday. So we got all kinds of stories on black holes for you. So we'll feed them to you a little bit at a time today. So it is officially Black Hole Friday.
Now, since it is Black Friday, and before we go there, let's stay in the solar system for a little while longer.
Sure.
Most people either love the moon or they hate the moon. I personally love it. I love to go out and look at it, put a pair of binoculars, put a telescope on it, remotely image it, and look at the craters, the rills, the mountain chains.
I'm kind of both. I'm a little bit rock and roll and I'm a little bit country. So,
well, yes. As I said, my other thing is, of course, is comets, which means really. I have the best of both worlds. When the moon's up, I can go look at the moon, and when it sets, and it gives me even 2 or 3 hours of total darkness, hey, guess what? I'm going after comets.
That's a good way to do it.
If there's nothing really I'm interested in, because I've probably imaged it already, there's always planetary nebulae, emission nebulae, all kinds of nebulae. And no, not unlike what we did for a show very many, many years ago. One of my friends looked up the nebulae entry on Wikipedia and changed it. He changed it to being the effect of when a TARDIS goes through a gas cloud in space. It generates a nebula.
Okay.
He promptly got told off by Wikipedia. It took him 3 days to realise it had been done. Come on, you weren't on the ball, Wikipedia. Now, as I say, I happened to be. I saw it and I said, no, I can't use that link anymore. And so I had to wing it a bit more and perhaps go a few other places and use some heavier science to go into what nebula were and the various kinds.
I know that you have your own science book. It's called Nicopedia.
Actually, I have many science books. They're not all called Nicopedia.
That you wrote.
I don't write science books. I just read them.
I swear there's a Nicopedia site out there somewhere.
Yes, it belongs to Nickelodeon.
Ah, okay.
Wrong, Nick. Nice try, Marty. Anyway, since it's Black Friday, this is probably going to be your last chance to get your hands on a really, really good set of lunar maps. What am I talking about? Okay, NASA and the U.S. Geological Survey did a pair of maps. It's 2 pages in size. They're about 46 by 41. I'll put a link into it. I am using the link from the shop at Sky because they're the guys who are selling it at the moment.
Okay.
And they have now dropped it down 75% to $4.99 a set.
Okay, let me check this out.
Yes, I have got a set on order.
Okay.
I also have a webinar from them on using PixInsight. So you can see where I am slowly going with my observatory.
Mm-hmm.
I spent a lot of time the last few days upgrading the observatory PC. I took out the old 256 gigabyte hard drive. I have put in a 1 terabyte drive. Why? Because Windows is one of those systems that loves hard drive space. And when I went to put in my favorite planetarium, it goes, not enough space for a full install. Well, the full install has the all-sky image from NASA, which is a humongous image. It is the main background they use for the planetaria program. So, of course, the other reason I wanted the full program on is because with ASCOM drivers, I can connect my scope to the computer. I can pull up my planetarium program. I believe you can also do this with a really high upgraded version of Stellarium. Mm-hmm. But I like the idea of putting my mouse on an object and hearing the sound of my scope slewing over to the object, and then tracking. So I can either use my DSLR or hopefully by Thanksgiving of next year, he says in a Jeremy Clarkson type voice, I should have an Attic 328 Plus. Yes, I've been convinced to go get an Attic CCD. Why? Because it has the Kodak chip that everybody in the really big top-of-the-line cameras made by people like S-Big and Finger Lakes, they all use the same chip because it is supposed to be very, very good concerning hot pixels. You get it nice and chilled down properly. You can pretty much eliminate them. You can also use your processing software to get rid of the hot pixels. Be careful with doing that, I say, because you can inadvertently remove the object you were imaging in the first place. People have removed stars thinking they're hot pixels. It does happen.
Yes.
So, 1 terabyte hard drive. I now have my favorite planetarium program, Starry Nights Proper 6, on. Nice. Why do I like it? Because I can set up the sky literally as I want. I can set up all the locations I want. I use remote telescopes. I want to see what is available to, say, Siding Springs telescopes, to the telescopes at Nerpico Astro Farm in Spain. I want to be able to use the Sierra Remote Observatory and know what their sky looks like. Particularly if I'm going for a comet and I'm creating plans that I'm going to upload to our telescope. So I'll upload it, I'll get my reservation in, and I'm going to go to bed. Because I am at the moment, I am a snow zone astronomer. In my winter, I get snow. But everybody north of me as well who has telescopes has to deal with it as well. So if you're at the Newfoundland Neutrino Observatory, if you are in Ottawa, if you're in York University, guess what? In the winter, we're going to get snow. Or when we want to go out and observe, it's going to be snowing. So, hey, just pop online, log into your favorite remote telescope, and set up the images you want. They have tutorials. This is what I love about iTelescope. Their tutorials are brilliant. They will take you through taking your first images to setting up plans. They will tell you which programs they accept the plans from. I have a program, an observing logbook program. One of the things it can do is to produce plans for telescope runs. I can tell it I'm using this scope in this location. It has this camera, and I can then set up an imaging. It will set everything up. It will set up the filters. It will set up the imaging, actual open aperture imaging runs. It will take into account everything. There are some really, really wicked programs out there that are well worth splurging out on. If you don't like one particular variety, there's at least 2 or 3 I know of that all cover the same territory. Some integrate logbooks, some don't. Can you hear something whistling in the background?
Sorry, I had a detector on. So I should shut it off.
So anyway, go out, get one of these programs if you want to do remote imaging. Why? Because at the end of the day, you only have a log. You can put the picture into the log. You can make your notes. You know what telescope you used. You know when. You know where. And you have something to fall back on.
How long?
How long? Yeah.
That's another important thing.
Yes, if you're imaging, you need to know how long you've got to do each imaging run for. Some scopes will say, oh, you have 10 minutes when the shutter is open. Boom. You have 5 minutes. Boom. Or you can use, or they tell you have to have a maximum time of, in most cases, I think with our telescope, it's either between 300 or 600 seconds. Scopes. So you have to use a piece of software called APC, which will let you write a plan. Now, Sky Tools from Skyhound will do exactly the same thing. The standard version, the basic standard version doesn't, to my knowledge, because it's really geared for naked eye observing. However, when you upgrade to certainly to the Pro version, which I have, you get the opportunity to actually write short programs. You can upload them to iTelescope. You can then pick the time for that particular scope and the date, and it's all set. You go away, you go back to bed, and it's there, and it'll be waiting for you after you'll be. Keep a notebook. Some people do the computer program, and they do a physical notebook.
So they have a hard copy in case.
Hard copies are always good. Thank you, Starstorm. Very correct.
As long as you keep them.
As long as you keep them. And to be honest, you should.
Yep.
Because sometimes something's going to happen. Now, if you, like me, like to put a telescope or binoculars on to, say, the Mare... oh, God, I can't remember.
On the moon?
Yeah, on the moon. One of them... the Sea of Tranquility, Marty.
Okay.
Yeah, and you could actually spend a lot of time just using a high power, a large aperture scope, just looking around that area. By keeping notes of what you see that night, if you come back, say, 3 weeks later, and you see that suddenly there's a new crater there, you may actually, or even if you come back the next night and you see something new there, because you've got those notes, you can go to the IAU, say, hey guys, there's a new crater in the Sea of Tranquility.
There you go.
I don't know if you guys realized it. Do I get bragging rights? And secondly, do I get naming rights?
Well, you don't get naming rights for that, but you might get it named after you if you discover it, though. You never know.
Absolutely.
Got a chance.
Now, Black Projects has put a link into the chat room.
Okay.
I'm just going to pull it up. In fact, yeah, he's just put an image he's taken of the moon for us to have a look at. That's a great image, Mark. Well done.
One of the many things I need to do is to get into iTelescopes. They were an early sponsor of Astronomy.FM. Really appreciate that. And I really need to get over there and start using their stuff, take some pictures.
Well, yeah, because what I do is that I may not use them every night. I buy my points, and I let them. Sometimes I let them. I think for about 12 months, I didn't use them. I kept paying my subscription, but I never used them. And I suddenly woke up to the fact, wow, I got a lot of points.
Nice. On the bigger scopes.
Well, yeah, you get one of the bigger scopes, or you can start setting up runs. Like, for instance, if you wanted to do a mosaic of the Tarantula Nebula, if you wanted to do something like Thor's helmet, you can get all your flats, your darks, you get your FITS files, you have an image that allows you gives you an idea of what you've got. So you can go and use your favorite processing program. A lot of people are moving to PixInsight from MaxMDL. PixInsight has a hefty learning curve. So does MaxM. But once you've got there, it's well worth it. There are tutorials out there. You can get tutorials from your favorite telescope magazine. They all do them. They all provide them on their websites because they want you to do well. They want you to get experienced, and they really want you to have fun doing astronomy. And to be honest, your images are always worthwhile having because they can be used as comparison images over time. And this is probably one of the greatest things about astronomy. We get to time travel.
There you go.
Most of the time, if we're looking at deep space objects, we are looking into the past. We are traveling into the past. We're seeing something that may be 220 million years ago. But it's still fun to do. It's still enjoyable. It's still science. Because even now, the photons are still continuously coming. So people take photographs, they take images, they're archived. Maybe somebody 2 centuries later needs to look at this because something's changed, and that they may actually be able to see the change because people are imaging this consistently. They're doing it in a scientific, high-quality manner so that the information is there, and perhaps, who knows, maybe Captain James T. Kirk or Captain Jean-Luc Picard will pull up your image on the Enterprise computer to compare it with what they've got right outside on their view screen.
There you go.
You just don't know. Okay, maybe that's being a...
I say here's a link to a Rochester Astronomy Club. They keep a list of bright supernova. Well, sort of bright supernova, and a lot of them actually use the iTelescope systems to discover the supernovas. Yeah. Now most of them are pretty faint. I mean, one of the brightest ones listed on the list is like 14th magnitude, and they go up to 16, 17, 18, stuff about there though. But I looked at them, and the sources, these people take the images with the iTelescope systems and find supernovas. But I didn't realize... Go ahead. I didn't realize that people are seeing actually a lot of nova in the Andromeda Galaxy. Not supernovas, but just regular novas. Stars that get brighter, but not really bright, and then fade down again.
Now, this is going back... Okay, another little time trip, if you wish. I'm only going to take us back.
Wait. Before you take us back, let's take us to station identification. You're listening to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one is November the 24th, 2017, 9:32 in the evening for those of us in the eastern portion of North America. So Universal Time, that would put it at 2:32, Saturday morning, November the 25th. 2017. So we still have another half hour of live programming for you. So stick around. And coming up afterwards, we're going to have Jodcast and Planetary Radio and more programming for you to listen into. And, of course, our chat room is open for you to come on in, ask us questions if you want to. We'll try to answer them on the air live for you. And don't forget, we repeat this program every 4 hours for the next 24 hours.
And go to the website, because that way you'll have all the links.
There you go. Yep, we're going to put some links to articles that we talk about on our show, so you can actually go to those links and read the full articles.
Yeah. Now, going back in time, I'm only going back about 4 days, because November the 20th was the anniversary of the birth in Marshfield, Missouri, in 1889, of the American astronomer Edward Powell Hubble. He provided the first reliable and persuasive observational evidence that the universe is expanding. Mm-hmm. He gave his name to the Hubble constant, which describes the rate of expansion. And he has a crater that's named after him. It's an 81-kilometer eroded and partially flooded lunar crater. It's called Hubble. It's close to the eastern limb of the moon and was named in his honor.
Nice.
So do things well and actually get science published. You too can get your name on a on a crater.
I have my name on a crater, but the road crew filled it in last week.
Now, Starstorm has asked us a question. Will space food improve with technological advances in the future?
Well, I say, of course it will, but I don't know about the taste. Thinking about like the Star Trek, food replicator. It is possible. It is possible to do that with basically 3D printing. So if you take the different types of food grade materials, and you could basically print out something and have it add flavor and texture and stuff like that, you should be able to make almost any kind of, meal with close proximity. It's certainly easy to make hot dogs, okay? Mush in a 3D printer, easy to make a hot dog. So, yeah, that will definitely be a lot of technical advances in food for sure. Improving in food, well, that's going to depend a lot on society. We're pretty advanced, but then there's people that are vegetarians or strictly, anti-animal killing, meat, stuff like that. So it goes both ways. So there's a social aspect of it and the science aspect of it. So.
Well, the thing is, if you're willing to eat tofu and soy, you can make it look like anything. Perhaps in the future, make it taste like anything. It should be fairly cheap. Soil should be fairly easy to synthesize or build on a spacecraft that's on a long duration voyage. And of course, Glenn, that's quite right. More homegrown veggies, because one of the things they are looking at for long duration space missions, particularly to Mars, etc., is having a greenhouse on the spacecraft. Hydroponic gardening, obviously, because soil takes a lot of energy to lift.
Again, that's more of a social thing. I mean, we could end up actually with less vegetables because more and more will go extinct. You can, in our short lifetime, it's easier to make things extinct than it is to develop new things.
Well, we also have things like heirloom seed banks as well, scattered around the world.
And genetic engineering, too. It goes.
Yes, the demon food.
Yeah. Well, it depends on the advancement of the technology. It's hard to say.
Yeah, the idea of splicing animal genes to wheat or to corn because it happens to come from a gene that produces a natural anti-bug, a natural bug repellent. Pesticide, yeah, that's scary. I think I like the Bruce Dern idea.
Yep.
Huge spacecrafts with domes, areas, hydroponic gardens.
Oh, kind of like in that one episode of Doctor Who that was on Mars.
Yeah.
That scared the living daylight.
Yeah, there you go. How to feed people on Mars?
The Martian.
Have a greenhouse.
There you go. What was that Bruce Dern movie called?
Dark Running or something?
Silent Running.
Silent Running, that was it, yeah.
There it is, yep.
Because,
go see that. Yeah, if you want to get sentimental over growing plants, watch that movie. Don't grow trivets in space, I'm trying to say.
A very dark section for fungi.
Yeah.
For your
There's an idea. Grow fungi in space.
For protein.
There you go.
Plenty of protein. See, that's the nice thing about Starstorm. She's got some really wicked ideas.
A little astronomy. Tonight, by the way, tonight anytime, Mercury is at greatest eastern elongation. That means it's farthest from the sun. Unfortunately, though, for northern hemisphere observers, the ecliptic stays pretty low to our southern horizon. So it's actually pretty difficult. Even though it's far from the sun, it only sets a little bit after the sun goes down. So it's rather difficult. So it would be another one of those good ones where you look for it during the daytime. A 22-degree separation between Mercury and the sun is pretty good. And Saturn's only like about 4 or 5 degrees away from Mercury, too. So, again, a daytime planet observing project would be good for that.
But it's doable. With a good telescope or a pair of binoculars, it's doable. Just watch where you're putting them and don't go too close to the sun.
That's right. So if you have like a building and let the sun drift behind the building, then go look for Mercury and Saturn. Yeah. That's the best way because you can't accidentally get into the sun that way.
Shall we do the sky at a glance for this week?
Let's do sky at a glance and go for it.
Okay. Right, Friday, November 24th. Yay, that's today. 2 challenge planets, no more than 20 or 30 minutes after sunset. Scan with binoculars low in the southwest for Saturn over Mercury, as shown in the image on the link. Today, they're 4 degrees apart. In the coming days, Saturn will move down a little closer to Mercury, passing to its upper right. So, whenever Fomalhaut South crosses the meridian due south, which it does around 7 p.m. this week, the first stars of Orion are just about to rise above the eastern horizon, and the pointers of Ursa Major stand upright due north, straight below Polaris. The 25th, Saturday, the bowl of Ursa Minor is descending the northern sky in the evening at this time of year. Left or lower of Polaris by about 11 p.m., it hangs straight below Polaris. On Sunday the 26th, first quarter moon, exact at 12:03 p.m. The moon shines straight above Fomalhaut as the stars come out at dusk. The moon appears to move to the upper right of the lonely star as the sky turns and evening grows late. On Monday, the moon is below the Great Square of Pegasus, forming a big triangle with Fomalhaut to its lower right, and orange Beta Cetae less far to the moon's lower left. This is for North America and Europe. Mm-hmm. And on Tuesday, the 28th, after dark, look below the waxing gibbous moon for Beta Cetae, and above it for the Great Square of Pegasus. On Wednesday, the 5 brightest stars of Cassiopeia, usually called a W, but now Cass is turning over to become a wide M, riding very high in the north by late evening. On Thursday, bright Vega still shines well up in northwest after dark. The brightest star above it is Deneb, the head of the big northern cross, which is formed by the brightest star of Cygnus. At nightfall, the shaft of the cross extends lower left from Deneb. By about 11 or midnight, the cross plants itself more or less upright on the northwest horizon. By Friday, December the 1st, the waxing gibbous moon shines up in the east this evening. Look upper right for 2 of the brightest stars of Aries, left of it for the little Pleiades cluster, and below the Pleiades for orange Aldebaran. On Saturday the 2nd, and I'm sure we're probably going to cover this again then, the nearly full moon shines in Taurus this evening, upper right of Aldebaran and below or lower right of the Pleiades. Does the moon look just a trace bigger than usual? You're right. Tomorrow's full moon is I hate the term. I really hate the term. A super moon. In fact, the closest full moon of the year. Now that the Pleiades and Aldebaran are up in due east, can Orion be far behind? Orion's entire iconic figure, formed by its 7 brightest stars, takes about an hour and a quarter to cross the horizon below them. By 10 p.m., Orion is well up in fine pre-winter view under the moon. So, something to do for the week. And I have to admit, at the moment, my scope is still packed away. It probably will be. Because it's getting bitterly cold here. I live in upstate New York, and when my temperatures are going into single digits, I am seriously looking at remote observing, purely because I hate the sudden change from summer to winter. It messes my lungs up, and I do not need to either go down with pneumonia or bronchitis every year by going out in the winter.
Well, tomorrow you get a nice day. We had temperatures in the 50s Fahrenheit, so you should be getting that tomorrow. You're in the downwind section of me, so
yeah,
tomorrow will be nice for you.
So take the binoculars out, most definitely. Play around with my mobile phone mount a bit more, perhaps, yes. I'd like to get that working properly. It's not a bad little piece of kit, and see what I can get snaps off. I did take a picture a couple of nights back, using my mobile phone handheld, using the rear-facing camera, because it's the better one. Not that brilliant, but you can see some shine on it, and it's always fun. But if I'm really going to get serious about imaging the moon without a telescope, I really have to get a tripod out, put the camera on that, put a telephoto lens on, and get my remote shutter release. And I'm going to be honest, only way you're going to get jerk-free pictures with a regular camera or a mobile phone is to use some form of shutter release or timer.
Yep.
Because as soon as you touch your phone or your camera, it's going to start vibrating, and you've just wasted everything you probably spent the last 3 hours setting up for.
That's right. And the more magnification you use on the moon, it's going to be a little bit dimmer, so you have to use a slightly longer exposure, so you better be tracking. Otherwise, the Earth's motion will actually get you. Monday is going to be an occultation of Neptune and the moon. That's going to be, unfortunately, visible from around Alaska and Western Canada. So not for everybody.
It happens. They'll come around again. They always do. There are plenty of sites that give occultations. Okay.
I've got a Bright Star occultation site, and let me pop that one in there. I like this one because it gives a nice list monthly. So I'll pop that into our chat room here. Now, this is just the moon and stars, but it also tells you where in the world to be to actually see those. So, for instance, we're kind of done with November. December 3rd, the moon's going to go in front of Aldebaran, and that will be visible from Northeast Asia, Alaska, and Northwest Canada. And then Regulus also on the 8th of December. Go ahead.
Now, I put the International Occultation Timing Association's link into chat because they are very nice people. They have a section for Europe, for the Middle East, for North America, and for Australasia. So no excuses, really, if you've got everything set up. They do recommend that you buy certain pieces of hardware. These guys are very friendly, and if you are getting really stuck on how to make everything work, drop them an email. Ask them for help, because they want to help you. They want your they want your results, they want your images, and they want your timings, basically. So because it's all put in and all used, it's checked, obviously, and verified. But at the end of the day, you are contributing valuable scientific information. And I think this is one of the greatest things about amateur astronomy. We are one of the few people, this is probably one of the few hobbies that is a hobby where you can work with the pros, you can image, you can do occultation timings, you can do variable star stuff. You can actually measure the dips, and the brightenings of variable stars, because that information gets shunted over to NASA and to LPI for use with Hubble. They will put out a request through the variable star groups for these if this information. They want to know how deep it goes in the dip, how bright it gets afterwards, and how long it takes, because they may be planning to use Hubble in that area of the sky, and suddenly having a variable star come right up full is going to do a lot of damage. And to be honest, we can't fix Hubble right now. Once Orion gets up and running, or maybe one of the new Super Falcons, or maybe even Blue Yonder gets up and running, then maybe eventually we can go back to Hubble and fix it. Marty, black hole stories, we're being asked for them.
I see that too. Yeah, John had a question about if I noticed any more fireballs lately. Well, we're kind of into a little bit of a meteor storm. What's it? The Leonids and the Geminids are coming up. Leonids just went by, and the Geminids are coming up. All right, let's see where we want to go. There's so much. If you go to the NASA website, all kinds of black hole stories. Let's see. What do we want to go with? Pick one here. Early black holes may have grown in fits and spurts in the early universe. Okay, let me put that article into our chat room there. So what that basically means is that instead of like a slow growth where the material basically just accretes down into the center, and the black hole gets bigger and bigger and bigger. And they're saying, no, it's looking like stuff falls into the black hole, it gets bigger, then it slows down a little bit, then more stuff falls in, it gets real bigger, then it slows down a little bit. So kind of like lumpy growth for early black holes, according to the Chandra X-ray Observatory.
Well, I think that goes pretty much for most black holes per se. They have times when they're active, and they're taking in material through the accretion disk. Then something will switch off. Perhaps there's the material isn't there to be pulled down and to be devoured. And then suddenly again they'll switch back on.
Well, early black holes, it would seem like it was not basically just stuff spiraling, or was not basically early stars that blew up in supernovas and left over a black hole and they combined together. It seems like basically the black holes just started by a whole bunch of stuff just crashing together. There were just so much stuff in a small space in the clouds that were making up galaxies, that the earliest galaxies. It seems like that the black holes in the centers of galaxies were probably not formed mostly by supernova explosions, but mostly by just stuff slamming together because it was so close to itself. Still more research on that. Well, we got about 10 more minutes here. Let's see where else we want to go. Yeah. Black holes.
Okay.
An article.
Let's go to Black Hole Meal sets record for duration. All
right.
Okay, so this is going back to February of this year. We seem to be doing quite a bit of time travel for some reason, but hey. Sorry. A giant black hole ripped apart a star and then gorged on its remains for about a decade. This is now 10 times longer than any observed episode of a star's death by a black hole. Now, they found this information. They made this discovery using data from the Chandra X-ray Observatory and SWIFT, as well as the European Space Agency XMM Newton. So you have a trio of orbiting X-ray telescopes. They found evidence for a tidal disruption event, a TDE, where the tidal forces due to the immense gravity from a black hole can destroy an object such as a star if it wanders too close to the black hole. Now, apparently, during a TDE, some of the stellar debris is flung outwards at high speeds, whilst the rest falls into the black hole. As it travels inwards, the material heats up to tens of millions of degrees, and it generates an X-ray flare. So what they've seen here is they've witnessed a star's spectacular and prolonged demise. And that's Da-Chung Lin from the University of New Hampshire in Durham, New Hampshire.
So basically, instead of just the star falling into the black hole, it was doing that what people always fear, the spaghetti effect.
Yeah.
You get a lot of tidal forces, and if you're like an astronaut and you get close to a black hole, your feet get stretched into the black hole before your head does. And if you're moving around fast enough, well, once you lose that weight of your feet, your body goes flinging out, your head goes flinging out into space. So you don't completely fall right into the black hole, but you get kind of stretched out and messed up from it.
And of course, the thing is, this is an extraordinary long bright phase for this type of event, spanning 10 years. That means they've observed, amongst the observed TDEs, this was either the most massive star ever to be completely torn apart. Excuse me a second.
Go ahead.
Sorry about that, folks. So, 10 years. It's either a most massive star ever to be completely torn apart, or the first where a smaller star was completely torn apart. So the X-ray source containing this force-fed black hole is known by the name of XJ 1500 plus 0154. It's located in a small galaxy about 1.8 billion light years from us. So it's a fair distance. It's taken a long time to get here and to be seen. But it was detected in XMM Newton on July 23rd, 2005, and reached peak brightness on a Chandra observation on June the 5th of 2008. So it shows that the source became at least 100 times brighter in X-rays. And since then, of course, the Chandra, Swift, and Newton teams have observed it multiple times. Now, Chandra has a very sharp X-ray vision, and it shows that it's actually located, that this black hole is located in the center of its host galaxy. The expected location for a supermassive black hole, pretty much most of them are going to be in the center of your galaxy. Our galaxy has one.
Yep.
The Andromeda galaxy has one. Pretty much, it's standard apparel for a galaxy.
Any galaxy that's anybody will have a black hole in its middle.
Oh, absolutely. And of course, the size thing is, of course, always the big issue.
That's right.
It's been a joke in chat.
There's been a joke in chat. What's the worst thing a black hole can do? Become a news event horizon. Thank you, Glenn. Nice one. Optronics has given us a joke. Wonder how many generations on Mars.
Question.
There's more of a question there. Yeah, okay. How many generations of humans on Mars would produce DNA changes?
Generations of humans on Mars will produce DNA changes?
I would have thought maybe after about certainly the second or third, given the amount of solar radiation. So I think pretty much from the second generation onwards, you may see mutation and DNA damage possibly.
Depends on how good the protection is too.
Yeah, I think that's
shielding.
If you're caught out on the surface, don't plan to have kids.
Depends on your shielding.
Oh gosh, that sounded too much like hamster just then. Plan to have kids. And if you're wondering who hamster is, it's Richard Hammond. I have to qualify that because here in the United States, most people, if you say Jezza, hamster, and Captain Slow, don't know who you mean. Jezza is Jeremy Clarkson. Hamster.
Slow is James May.
Thank you. Oh, then
for obvious reasons.
For obvious reasons.
Yeah.
But we're digressing. We're digressing.
Here's an article about the sun. I guess we should have done this one earlier, but potentially another way of. Did I get that right? Yeah, I think that's right. Link there. A way of heating the solar corona. So they're trying to figure out what heats the corona. There's basically three parts of the sun: the photosphere, parts of the atmosphere. The photosphere, right above that's chromosphere, and above that is a corona, the outer atmosphere of the sun. Sun surface about 5,500 degrees Kelvin, something like that. But the corona out farther away from the sun is up around 1 million or a couple million degrees. So what's heating it? So they've been trying to figure out what's actually heating up the outer atmosphere of the sun. We know, of course, about solar flares. It generates a tremendous amount of energy, but doesn't seem to be enough energy to heat that sun, that outer corona, up to 1 million degrees. Well, one way now they're thinking is maybe there's a lot of nanoflares, really, really small flares all over the sun, and they're starting to actually detect a variety of hard X-rays in active regions on the sun that are not currently flaring. So usually when an active region flares up, then we get a lot of X-rays, and it's pretty easy to detect. But now they're actually starting to see X-rays coming from active regions that are not flaring, and this might be enough energy to actually heat up the outer atmosphere of the sun. The article is in Nature Astronomy. Check that out.
Okay, keeping an eye on the time. An article: Does dark matter and dark energy exist? 1933, Fritz Zwicky claimed there's substantially more matter in the universe than we can actually see. They called it dark matter. Basically, I'm going to have to say I think the jury's still out. We haven't figured out a way to prove it, but we know something is holding the galaxies together and something is trying to push them apart. Mm-hmm. That is dark matter and dark energy. I think basically once we may have better terms and better ideas in the next 20 years, but for now I think they're going to have to do.
Yeah, you can tell that when a galaxy bends the light of the galaxy behind it, and then you kind of figure out how many stars are in the galaxy in front. It's not enough stars to bend that light to have enough gravity, so that's where they come up with dark matter. Well,
yeah, this is true.
That's about it for us, Nick. We're kind of running out of time here.
Yeah, I know. Sadly.
So, I know. Time for us to head on out. Appreciate every... What was that? What was that?
Oh, it's the call from the ship. This is the away team to USS Miranda. Captain, somewhere there's a cup of tea getting cold. It's time to get me, Starstorm, and Marty out of here. Let's beam up and have a nice warm cup of tea.
Thanks, everybody. Appreciate you all listening in and appreciate you, those of you that were in our chat room tonight. I think we'll be here next week also, I think. Yep. Is it? I think so too, next Friday.
And all right, everybody. Godzomisa, if you're listening in Japan.
All right. Thanks, everybody. Good night, all.
Good night. Clear skies. Look up.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing.